So continuing from the last Saturday, we were solving the binary source problem. So we'll continue with the binary source problem from the LeetCode. Okay. So today we'll try to solve Coco eating bananas. Okay. Problem. So Coco eating bananas. Coco loves to eat bananas. There are n piles of bananas, and nth pile has an pile bananas. The guard has gone and will come back in H hour. Who can decide how bananas per hour it is speed of k? Who can decide bananas per hour it is speed of k? Each hour she chooses some pile of bananas and eat k bananas from the pile. If the pile has less than k bananas, she eats all of them instead, and while will not eat any more bananas during this hour. Cook likes to eat slowly but still wants to finish eating all the bananas before the guard returns. So return the minimum integer k such that she can eat all the banana within each hour. Okay. So this is pile. This is hour we have before the guard returns, and we need to return the value of k. So there is 3, 6, 7, 11. So how can we solve this problem? She wants to eat all the bananas. From the minimum integer k such that each she can eat all the banana within k. So simply, if we think what if we plus all of this, because we will get total number of bananas by combining all the integer. Okay, and then dividing it by 4, so that will give us how many how to take how to be. Okay, so let's try with my calculator. Plus 6, sorry, 1 0 0. Start the clock. Start the clock for 30 minutes. 3 plus 6 plus 7 plus 11 divided by 8. That is 10.8. So how many bananas should eat? Minimum. So minimum is a cases that she can eat all the bananas within each hour. So minimum k. So if she eats 10 bananas per hour, if she eats 10 bananas per hour, she can. So let's start. She will eat this one in 1 hour, eat this one in an hour. When it comes to this, she will eat 10 bananas. In this hour, so next hours, 5 hours, she can eat all the bananas. For 1 hour, 2 hour, 3 hour, 4 and 5, 6, 7, 8. So 8 bananas. So 8 hours. If we eat 4 bananas per hour, we can all of this in 8 hours. But she wants to eat slowly. Okay. So how can we solve this problem? So we know that it's binary. We know that it's binary source problem. So we can like if we sort this, get the minimum, the middle, the pack. So this is already sorted. If we get the middle, that will be 1, 2, 3, 4. 4 divided by 2, that will be 2. So 6. 6 if see it's so Coco loves to its banana. There is n piles of banana. The ith pile has 5 I bananas. The guard has gone and will come back in H hour. Okay. So I think instead of like it's a basic math problem. If you know the formula of how to do it, how to calculate this, it will be easy. Okay? So we need to figure out. Okay. So 8 hours. If we calculate all of this, we get certain amount. So if we see this, that we have 10. We can if we have if we eat 10, we can eat almost 10 bananas per hour. Okay, but we have only the total. What's 3 plus 6 plus 7 plus 11. That is 27 divided by 8. That is 3.351. Let's move on to this problem. 13 plus 11 plus 23 plus 4 plus 20 divided by 5. That is 11.6. Okay, so see if it's 11.6 bananas. Okay. If it's 17.6 bananas per hour second, simply it's if it's 17.6 bananas per hour second, finish all of this. Okay, but if it is in one place, but basically it is not in one place. So what can we do? Like for 11, let's say 1 hour, 2 hour, 3 hour, 4, 5 hour. So 5 hour will be reduced 1 here. So let's say if we sort all of these, now we have sorted, and then we have 8 bananas. So we go on to the middle, that is the one iteration with 8 all of this. Second iteration, we pop this up. We want to get all of this second, third hour. This what we got all of this. We need value k so that we can eat all the bananas. 5 hours. So minimum is 8. How can we solve this problem? Solve this. in 10 to 5 to 9 in that it should be 5 hours. 5 9 5 but 8 also 5 hours 7 also 5 hours 6 and then we have 6 hours. So if we want to solve it in OFN, not in OFN, what we can do is take the highest number. That's 27. Divided by 11. So on. So what we can do is simply see if that's 4. So highest is 11. So whenever the highest is 11, there is 4. So we can get whatever in this much amount. If there is 5, if highest, we can see if we have highest amount. Highest amount is equal to the number of hours. The highest amount is the highest amount. If the length is equal to h hours, we can simply choose the highest element. Okay, so we can simply choose the highest. If it is greater than, we can be sure that it's not highest. What we do is it is the highest by if it is more than we have 5 to 5, that's finished. If we have 30, then we have 11, 23, 4 and 20, that is 6. So if we choose 30, then we can solve this in almost 5 hours. So but we have 1 hour to spare, 1 hour extra. So what we can do is then 1 hour as an extra. So what can we get like this specific it's 11 20 okay, 28 6, that is 14 14 for this. So if we choose the highest, 30, then we have 5 as 1 hour as a sphere. Now we can get what 17, 14, 1 hour. So we can get 14 in 1 hour. search array and search strings. Let's go through the header. So given h is always greater than or equal to the length of file, can you determine the upper bound of the answer? How much time does it take to propagate file with x values? Given an h is always greater than or equal to the length of the file. So it's equal get size equal h, and then just return simply return x alpha get x alpha that's okay. Excellent. So that's here. It's written. That begin. That's that end. Now if value proportion time value. So that's a point. So we can be sure like can be determined by the upper bound. Given h is greater than or equal to the length profile, if it is equal to length profile, we can be sure that highest will be the highest in that will be the amount k. Because if both are the same, it can eat only one. So if it is small, what if it is smaller than we put it in this label. Okay, so whatever the highest is, it will be less than the highest. If it is greater, still given h is always greater than or equal to the price, can we determine the upper bound for an answer? So we can determine the upper bound for an answer. We can be upper bound. How much time does it take to eat pie with x bananas? How much time does it take Coco to eat pie with x bananas? If there is x bananas, then it is how much time does it take the Coco to eat the pile of x bananas? So if we have greater than or equal to the pile, can we determine the confidence? So it is the same x by k. Finish the x bananas pile and when put it at the rate of k bananas per hour. Our task is to determine the minimum possible value of k. However, we must also ensure that at this rate k, Coco can finish eating all the pile within the given x hours. Can you think of what amount of k? Upper bound for k would be basically the highest amount of the greatest amount in a file. Okay, so we can do that. Bound for k is the maximum size of the file all file array. Why? Because if the Coco eats the largest file in 1 hour, it is straightforward that she can eat another file in an hour. So that we know that. So Coco can eat the highest file in 1 hour. So we need all of them. So it will take whatever the size is. So what we need to do is reduce the file such that reduce the size such that, like, if 25 is the max. Okay, so in this case let's say 30 is the max. So 1 2 3 4 5 she has 1 hour to spare. So what we should do now, what we can do is reduce the 30 32 and 30 is the second highest. We will do the 32nd highest and see if let's see, just let me second highest. If we do second highest, so what we will do is simply int k is equal to so that is max. So if this condition is true, we can show that second max. So what is the second max? So before that we need to sort the pipe, ascending or descending, whatever. So let's sort the pipe. Sort begin. So if we solve this take this basically size minus 1 and just create and it's going to size. Okay, and so $23. So we can add 1 hour if we do second highest. Second highest. I can calculate. So instead of calculating second highest divided by max highest, 23 divided with 2 hours. 1 hour, that is 2 hours, that is 2 hours, 2 hours. We have all the limits. So what we will do is we can start from the end of the sorted list. So let's say if we start from the end of the sorted list. Three, so it is 1 2 3 hours, 4 5 and 6 hours, 7 8 9 10 hours. So we're going to show that it's not 3, so it's greater than 3. So, it's primary source problem. We'll see all the elements after this. So all the elements after this will take more time. So how much more time it will take? How will we that? Keep on dividing all the elements after that. Total problem. It is the binary search problem. We'll just do it in different ways. And while I is less than where I is zero, plus sorry, I minus plus all in its place. So if I is n, so we know that so it cannot be n minus 1, because if it's n minus 1, we already have gotten the answer. So this is just 30. So it is not that. That's it. We can be so this to one after the so not I put the second highest. What we do is simply get the time this one front of so that is repeated. So it's written files are what it is while okay. So 23 for 11 it did not work, for 7 it did not work, for 6 it did not work, 3 it did not work. For 3, if we 3 bananas per hour, we can in 8 hours, so we can be sure that it's above 3 6. So 3 plus 6,009 divided by 4. So what we can do is simply keep on reducing 23. But it will take a lot of time. Like if the pile is too big, so first we are sorting, then we are doing this, then we keep on comparing it to all the elements in front of in front of this to get our k. For this problem we check for this one. So for this one we don't have, so just 7 we divided 7 divided by 11, so that is equal to 7 divided by 11, that is simply 2, so that is 2. We'll do the upper bound. Okay, so we know we take 2 times to eat this all of these, so 1 2 3 4 plus 5, 1 extra, so only in 5 hours they can eat. And for 6 again we do this, so 2 hours for this, 2 hours for this, 2 to 4 5 1 6, all in 6 hours. So if you do 3 So 2 out for this, 3 out for this, 4 out for this. That will be more than 8. So we can be sure it's above 3. Okay. So then we do it for 4. 4 we can get it 2, 2, 3. So 2 and 2, so 3, 5, 6, 7 or 8. So we can solve it like this, like currently we did it. But if you try to solve it like this for the large sequence of pi, it will take a lot of time. I think we'll get the time exceeded 1 if you try to do this. Is there any other way? We have already sorted with 4, 6, 4 middle element. If it is not, we check for another middle element. Let's say if we are instead of checking for all the possible cases, what we will do is simply we'll sort this. So 11, so 4, 11, we'll have 4, 11, 20, 23, 30. So we need 6. So what we do is simply take the 20. So we have already have more than this. So we already have 1, 2, 3, 4, 5 hours. So we need more hours. So we already have 5 hours. So we take 20. We divide it to this. So we get. So we divide it to 2. We get 2. So we already have 1 added. So we'll add 1. That will be 6. If this does not listen, we need to eat in. Instead of 6, we need to eat in 7 hours. So what is it? We do this. We have 1, 2, 3, 4 hours. This will give us 2 hours. That is only 6 hours. So what it is again? We know we get only 6. We need 7. So we need to reduce this again. So we'll reduce this to here. So median of these two, that will be this 11. So for 11, what we will do is simply for 11, we'll again calculate to get the this one. So that will be 1, 2, 3, 4. Give us 1, 2, 3. So that will be 1, 2, 3, 4. 4, 3, 7. That will be 7. So that is 11. If we eat 11 bananas, like this will give us 1 hour. 1 hour. This no. This will, so all the elements above this will give us more time. So if we do this, this will take 3 hours. This will take 2 hours, and this will also take this 3 hours. So that will be 1, 2, 3, 4, 7. So we can so it's not 11. So it's between 20 and 11. So when we get a median, that is 20 plus 11, that will be 20 plus 11. So that will be 20 plus 11, that is 31. 31 divided by 2, that will be 15. This is 16. If we eat 16 bananas per hour, 1, 2, 2. So 2, 4, 2, 4, 5, 6, 7, 8, 9. So it's still more than minute. Hour, this will also take 2 hours, this will also take 2 hours. So again, what we do, we know that it's between these two. Okay. So again, it's between these these two. So it will be 16, 11, 22, 22 plus 4, that is 26. 26 divided by 4, that is 14. So 14 I will use, which will give us 1, 1, 2, 2. Oh, sorry. It will be between these because we are eating less. So that will be 20 plus this 46 divided by 2, that will be that will be 23. So you get 23 bananas. So 1 hour, 2 hour, 1, 3, 4, this plus 2 hour. Still there will be 6. So we split with these two. So I will create 21 bananas. So 1 hour, 2 hour, 1 hour, 1 hour. So 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3, 4, 6, 7, 8. 8 hours. So still is not this. So we will do 20. So 20, 1, 2, 3, 4, 5, 6, 7, 8. Still not. Okay. More bananas. More than 20, we miss the point. Let's go to the solution. Let's use this.
Hey everyone, welcome back, and let's write some more NeetCode today. So today let's solve Coco eating bananas. But before we do, I just want to say that if you do have any requested problems, you can feel free to leave those in the comments. I do have a large backlog of requested problems that I'm working through, so it may take some time for me to get there, but you can feel free to request at any time. And if you find this video helpful, don't forget to leave a like and subscribe for more videos. So this is a pretty interesting problem because there is a brute force solution that we can arrive at, and that brute force solution can easily be transitioned into a binary search solution, which is the optimal solution for this problem. So we're going to be working our way from the brute force to that binary search solution. So Coco loves eating bananas, and we have n piles of bananas given to us in a piles input array. We're also given a second parameter, h, which is the number of hours that we have in order to eat all of the bananas. So we have to eat them with...
Brute force will be like get the highest. Okay. Get the highest. Okay. That will be this. And reduce it by 1 and increase it by 1. So this will be again 1 hour added. So we again add 1 hour. If you do 9, so 1 hour again. No, keep on reducing these values. Getting all the reminders, adding it, seeing the hour
within h hours. And so Coco has a certain eating speed where she can eat a certain number of bananas per hour, and that variable happens to be k, and k is not an input variable. That's what we're trying to determine as the solution for this problem. Each hour, she can only choose one pile of bananas and eat k bananas from that pile. So that's what we're trying to determine, that k value. If the pile has less than k bananas, she'll eat all of the bananas, but she's not going to eat any extra bananas from a different pile. So what we're saying here is Coco can only eat at most one entire pile of bananas in a given hour. So what does that tell us? Already we're given some key information. Let's say we're given a certain number of piles, right? So basically the length of p, h must be greater than or equal to the length of p. Why is that? Because let's say we have 5 piles, right? So let's say we had 5 piles, and let's say this is what the piles look like. The values aren't too important, right? 1, 1, 2, 2, 3. And let's say we had h equals 4 hours. Well, let's say k equals some really big number, like 3, right? Basically the max of this input array. Okay, Coco ate this entire pile, Coco ate this entire pile, this entire pile, and this entire pile, because she could only eat 4 piles because we only have 4 hours, right? Coco can only eat 1 pile per hour. So if she ate all 4 piles over here, we'd still have 1 left over. That's why they guarantee us that h is always going to be greater than or equal to the number of piles. So the minimum in this problem, given this input array, h, the minimum it could possibly be is going to be 5. And I sort of wrote over it, but the last important thing that they tell us in the problem is we want to determine that eating speed k that Coco is going to eat at, but we want to know the minimum integer k, the minimum eating speed of Coco, that she could eat all of the piles in exactly 5 hours, or exactly whatever that time interval, that number of hours happens to be. So let's take a look at this example. They give us an input array of 4 piles, and they give us 8 hours to eat all 4 of those piles. What's the minimum k, the minimum eating speed that Coco could use to eat all of these piles in at most 8 hours? So we have to eat all the piles in 8 hours or less. Well, the brute force would be to start at 1, right? Because Coco could try k equals 1, right? Can we eat all piles in 8 hours then? Well, it will take us 3 hours to eat the first pile, right? 3 divided by 1, which is our k, right? 3 divided by 1 is going to be 3 hours to eat this first pile. And to eat the second pile is going to be even more. That's going to be 6 hours, right? 6 divided by 1, 6 hours. So far we already have 9 hours, and we haven't even eaten the entire number of piles. So therefore, k equals 1 is not going to work. And we could just continue this brute force approach, right? Now try k equals 2, right? And then do the exact same computation with k equals 2. Now, my question to you is, we know that the minimum possible solution would be k equals 1, right? K can't be 0 because that would mean we're not eating any pile. So the minimum is 1. What's the maximum that k could possibly be given this input array and given this number of hours? Well, remember, the number of hours is always going to be greater than or equal to the number of piles. So in the worst case, k would basically be the max number that happens to be in our piles. For example, if k equals 11, right, that means we're able to eat the max pile in exactly 1 hour, right? And if we can eat the max pile in 1 hour, that means every other pile is also going to take us only 1 hour. So therefore, we're going to eat every single pile in 4 hours. And we know for sure that this is going to be less than whatever is given to us as h, right? We guaranteed that at the beginning. So really what we're doing here is we're going to try every single value from 1 all the way up to 11, which happens to be the max value of our piles. And the first value that we get that allows us to eat every single pile in less than or equal to 8 hours is going to be our output. So we're going to end up trying 1, we're going to end up trying 2, we're going to end up trying 3, and we're going to find that 4 allows us to eat all the piles in less than or equal to 8 hours. So this is not a terrible solution, right? Even though we're brute forcing the entire solution set 1 through the max of piles, it's not going to be terrible. What's going to be the complexity of that? Well, we're potentially going to have to iterate through every value in this potential solution set. What's that going to be? Well, 1 through the max value of our piles, right? So it's going to be, let's say, big O of the max value of piles, so max of P, multiplied by the length of P, because for every K value, we're potentially going to have to try, okay, if I eat all these, how many hours is that going to take me, right? So we're going to have to iterate through this entire array for every K value that we try. So we're going to get a time complexity of max of P multiplied by P. Right, but that's only, we're getting this max P from the fact that we're having to iterate through every single value in this K range. But why should we iterate from 1 to the end of that K range? Why, in which case, in the worst case, we'll have to go through every single value. Why don't we instead apply binary search on this K range? What's that going to give us? Well, we can reduce max of P to the log of max P. So if we can improve this, this is what our time complexity is going to be. Okay, so I ran out of room, but this is the improved time complexity. Basically, we're taking this variable and applying a log to it, which is going to reduce it a little bit. So let me show you quickly how that binary solution is going to work. It's pretty straightforward, and then we're going to jump into the code. So we're going to be using binary search. We're given this input array, and we want to eat every single pile in less than or equal to 8 hours. So we know that the potential rate that we're eating bananas at, K, is going to be between 1, that's the minimum it could possibly be, the max it could possibly be is going to be whatever the max in our input array is. We know the max value is 11. We can find that in linear time. So then we're going to initialize a range like this, right? This entire range that we have going all the way from 1 to that max value 11. So in other words, we're going to have a left pointer at the minimum and a right pointer at the maximum. Then we're going to compute the
At we can long buffer. Like for 6, if it is in decreasing order, we can check. We know what the size is. So 1, 2, 3, 4, 5. So 5 is fixed. Then we get the remainder. We'll subtract 1 plus whatever that is. We'll get this one. Subtract 1. Remind this. And we do this. If we do from back, if we can get if we get higher than h, okay, or equal to h, we can be sure that it's 60 times. Okay.
middle by taking the average of left and right. 1 plus 11 divided by 2 is going to be 6. So our middle is going to be here. In other words, our k that we're trying is going to be here. This is the rate that we're going to eat bananas at. So we're trying the rate of 6. Does this work? Can we eat all these bananas with a rate of 6 bananas per hour in less than or equal to 8 hours? Can we do that? Well, how many hours does the first pile take? Well, 3 bananas, right?
I got it. Okay, so let's continue. So what we did, int hours. Okay, so what it is, it will be simply whatever the file state size will be by default hour this one much. So what it is, start from the end. So upper one. So that is it twice. Okay. So upper bound. Upper bound function. Start from the end. Okay. So let's look at last end. So let's scripting. What do we have? We have simply what we have. We have simply script. And CIL CIL. Okay. So here is CIL. By divide by I dividing whatever the possible result. So that is, so what we will add minus 1 here. Hours plus equal to x objective hours equal x. How do we simply do this? Simply return. What do we return? We simply return set so if this is not possible, if it is not available, keep on going back. If for some reason hours, then if it is not available, we move on to the next one. While hour is less than hour is less than or h. So you need to remove this. So let's make it simple. So let's press this then. First, if we become greater than this, then it is simply wait. Okay, let's keep on going back. If hours become greater than h, just get this, then we go. So if it becomes greater, this special is for 6 from me, it becomes greater. Well, so from 0 to 23, so 30, from 15 it becomes 15 will become greater. So you know that it becomes greater. This problem, what it is, so 6 for 6, 1, what it is, 1, 2, 3, so 1, 2, 3, 4, 5, 6. If it becomes greater at the end, in the middle, what we need to do is, let's say for 6 it becomes greater, so it's for 6. You can be sure that for 6, for this it does not, so it is smaller. So what we need to do is, we need to do simply what it will, low will be mid plus 1, higher simple. If at the end of the loop, if 6 greater plus 1, then hence what we need to do is simply it's high, so it's will be mid minus 1. Get the answer, or we so what we can do is, let's see, start from that. If we get greater, so let's say if it's 6, let's say we choose 3, so we for 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, so we get greater than this, so we can be sure that it is greater than this. So whatever 3, so it is greater than 3, so it is greater than 3, what will low is equal to mid plus 1. If we do 6, this is 6, so 6, we get at the end of this loop, from start from here, went till here, will when neither this is true nor this is true, so this will be true. So if this is true, what we do is simply change it to this one. Again, let's, instead of doing this once every iteration, let's set it back to this one, file dot size, that is n, that is n. Okay. Start. Please paste here. X. X. Bytes. Okay. So what's the issue? When you get the need need to need values. So what you need value the high need is return zero zero. So this is now true. Um, so it's next element point used to be one. So 1 plus 12, 1 plus 11, that is 6 plus 6. Because 6 minus 1. 6 minus 1, that is 5, 6 minus 4, 6 minus 5, 5 plus 1, that is 5 plus 1. 5 plus 1, that is simply 6 is divided by 3, so 3 also 2. So 3, 3 is by 1, so it's going to be 1. 4 plus 2, 2 plus 5, that is 2 plus 5, that is 7. So it will reduce to have, it will reduce to have, get 3, 4 plus 2, 4 plus 2, that is 6. Okay. Then this will be 3, so 3 plus 4 is 7 again. So again it will come back by 4, 4 plus 4, 2, that will be 8. 8 plus 4 is 6. Right. So this is called minimum hour, that is dot size. Points dot size that will be this problem and 344. So just source. So this one. With value of, let's say, 6. So this is 11 plus 1, that is 6. So 6 divided by 11, that should give us 2. Level 6, that will be divided by 0, which gives 2. So 6 divided by 11, 6 divided by 3, that gives 2. This is 11, 6. So 11 divided by 6, that should be 2 point something. This is 127. So what if we let's subtract 2. So hours. Where's our total? This is total standard size. X. So it's hours. CD data. Four, this 4 divided by 7, let's do this. Let's do this. This. 4, 7, this 2. That is 4, 7. That is 7. This 2 as now. So that 2, that is 6. So it was approximately 3, and then we have 34, 10, 4, 8. So this is fine is this, hours like this, keys to be. Right size take this. One. So is that get these, get this level was 3. Three. It
divided by the rate, which is 6, is going to round up to 1. That means it took us 1 hour to eat the first pile. The second pile, 6 divided by 6, is also going to take 1 hour. So let's just count the number of hours. So the third pile, 7 divided by 6, is going to round up to 2. So that's going to take 2 hours. The third pile, 11 divided by 6, is going to also round up to 2. That means 2 hours. So we just did this in 6 hours, right? Is that good? Does that mean we found our solution? Well, 6 is less than or equal to 8. That means we were able to eat this entire thing in the time threshold with a rate of 6 bananas per hour. Is this our solution? Well, remember, we were looking for the minimum K value that allowed us to do this. So this might be the solution, but let's try all the smaller values, or let's start our binary search in this direction to see, is there a smaller value than 6 so that we can use for our K value? So basically what I'm doing here is, if we're able to eat the entire pile in the threshold, what I'm going to do is then start searching in the left direction. So what I'm going to do is take my right pointer and shift it to K minus 1, because now we're searching this entire range. What if the opposite was true? What if I tried this K value, but I was only able to eat the entire banana pile in, let's say, H equals 10 hours? That means I went over the threshold, right? That means I went over the time. So what does that mean? Does that modify our binary search? Well, what that tells us is our rate of eating bananas 6 was too small. We didn't have enough time to eat all the bananas in the given available time. So what we have to do is increase our rate of K, right? So in that case, what I would do is I would search the right portion of the range. So what I would do is take the left pointer and set it to k plus 1 over here at the 7. So that's how this binary search is going to be working. So far, we do have one possible solution, and that's 6. So now our new right pointer is pointing over here, and our result is for now going to be 6. So once again, we're going to take the left and right, add them together, divide by 2. That's going to give us 1 plus 5 divided by 2 is 3. So our k is now going to be at this 3 value. So now let's check. Can we eat all the bananas in less than or equal to 8 hours? How many hours does the first take us? Well, we're eating at a rate of 3 bananas per hour. The first pile is 3. That's going to take us 1 hour to eat it. The second pile, 6 bananas divided by 3. That's going to take 2 hours. The third pile, 7 divided by 3, rounding up, is going to be 3 hours to eat that pile. Last pile, 11 divided by 3, rounded up, is going to be 4 hours. So when we total all of this up, it's going to give us, I think, 10 hours. So just like we discussed before, we went over our threshold. We took too long to eat these bananas. So what that tells us is this did not work. 3 bananas per hour doesn't work. Let's start searching to the right of our range. And remember, when we took this right pointer and shifted it, what we basically did was we said that none of these values are ever going to be considered again. We're now searching in the other range. That's how binary search works, remember? So since this did not work, we're not searching it, and we're not going to search any of the values to the left of it. So what we're going to do is take this left pointer, set it to k plus 1. So once again, we're going to take our pointers, add them together, divide by 2, and in this case, we'll just round down. So 9 divided by 2 is going to be 4. So I'm going to put my k value basically where left happens to be at 4. So let's see, with the rate of k equals 4, can we eat all the bananas in less than or equal to 8 hours? The first pile takes 1 hour, the second pile takes 2 hours. All the where left happens to be at. So 9 divided by 2 is going to be 4. So I'm going to put my k value basically where left happens to be at 4. So let's see, with the rate of k equals 4, can we eat all the bananas in less than or equal to 8 hours? The first pile takes 1 hour, the second pile takes 2 hours, the third pile takes 2 hours, and the last pile takes 3 hours. So totaling all of this up, we get 8, right? So we were able to eat all the bananas in less than or equal to 8 hours if we had a rate of 4. So basically, let's compare that to our current result. So far, we found a value with 6. So really, we can update the 6 and say there's a smaller rate that we can use that happens to be 4. So now that we did find a potential result 4, let's see if we can find an even smaller one. Remember, that's what we did before. If we find a k that works, we're going to try to find an even smaller one. So what we're going to do is we're going to set our right pointer shifted over here. But notice how now the left and right pointers are not in the correct order, right? Left should always be to the left of the right pointer. That's basically how you know that our binary search has stopped. We don't have to continue the binary search anymore, right? And that makes sense because now we're searching values that we previously crossed out. We crossed these out, so how can we search them again? It makes no sense. So now we can stop the binary search and we can return the current result, which happens to be 4. 4 is the minimum rate of bananas that Coco could eat to eat all bananas in less than or equal to 8 hours. With that being said, let's jump into the code now. So just like I mentioned, we are going to have our left and right pointers initially set to 1. Left is going to be 1, and right is going to be the max that happens to exist in our piles input array. Now, the result, we're not going to initialize it to 0 initially because remember, we're looking for the minimum, so I'm just going to initialize it to r, which is the max in our piles because we know at least this will work. This is the max that our solution could possibly be. And now we just start binary searching while our left and right pointers are in the correct order. We can compute the k by adding the left and right together and dividing by 2. And we want to count for this value k, for this rate k, how many hours does it take to eat all bananas? So let's initialize hours to 0 and go through every pile in the input array piles. So for any given pile p, we can divide it by k, which tells us how many hours it took. But remember, we have to round up, so there's a function in Python, math.ceiling, which will round this up for us. And whatever that happens to be is what we can add to our hours total. Once we've done that, then at the end of that loop, we're going to check if hours happens to be less than or equal to h, the given input. If it is, that means we can update our result to a new minimum, right? Take the minimum of the result, and whatever k happens to be k is that rate that we're looking for. And if this is the case, then how are we going to update our binary search? Well, we're going to look for an even smaller k. So what we're going to do is set our right pointer equal to k minus 1. We're going to search the left portion now. If this wasn't true, how would we update our binary search in the opposite case? Then we would take our left pointer and set it to k plus 1, because that means the rate was too small, so we need to find an even bigger rate that will allow us to eat the bananas in the given time interval. And at the end of this loop, once the binary search has stopped, we know that we're going to be returning that result variable, which tells us what the minimum k happens to be. And believe it or not, that is the entire result. So I hope this was helpful. If it was, please like and subscribe. It supports the channel a lot.